There is a mattress in every bedroom, every hotel room, every motel, every dormitory, every hospital, every shelter, and every abandoned house in America. After a collapse, roughly 350 million of them are going to sit there doing nothing while people sleep on the floor next to them because a mattress is for sleeping, and they have already got a spot on the concrete. That is one of the biggest wastes in the entire post-collapse landscape, because a mattress isn't just a sleeping surface. A mattress is a compressed bale of raw materials that were assembled in a factory using steel, foam, fabric, cotton, wood, and fiber. These are materials selected for durability, resilience, and performance under sustained physical stress, all wrapped in a convenient rectangular package that you can drag to your shelter, cut open with a kitchen knife, and turn into 6 different survival systems that would otherwise require scavenging across a dozen locations. The people who see a mattress and think bed will sleep on one. The people who see a mattress and think materials will strip it apart and use those components to insulate a shelter, build traps, filter water, dress wounds, start fires, and construct the kind of infrastructure that keeps a group alive through a winter. Here is what is inside and what each component does. A standard inner spring mattress contains between 300 and 800 individual coil springs made from tempered high-carbon steel wire. Each one is preformed into a helix roughly 3 to 5 inches tall. This is an absurd quantity of quality steel wire concentrated in a single object. When you clip those springs free from the frame that connects them, a task requiring nothing more than pliers or wire cutters, you are holding individual units of springy, strong, corrosion-resistant steel that have been heat-treated to maintain their shape under thousands of pounds of repeated compression. Each spring, uncoiled and straightened, produces roughly 12 to 18 inches of usable wire. Multiply that by 500 springs, and you are looking at 500 to 750 feet of tempered steel wire from a single mattress. That wire makes snare loops for small game. The spring temper means it holds its loop shape without collapsing, which is the exact property you want in a snare. It bends into fish hooks that hold their shape under pulling force. It twists into tripwire connectors for perimeter alarm systems. It forms into pins, needles, small tools, and trap trigger components. Because it is already tempered and heat-treated to be hard and springy, it performs better for these applications than raw wire from electrical cables or fences, which is softer and deforms more easily under load. The spring coils themselves, left intact, have applications that straightened wire does not. A coil spring is a mechanical energy storage device. Compress it, and it pushes back with proportional force. This makes intact mattress springs useful as trigger mechanisms for traps, return springs for improvised latches and gate closures, tensioning devices for snare systems that need to snap shut, and shock absorbers. A handful of mattress springs gives you a mechanical component almost impossible to fabricate without a forge, enabling dozens of mechanisms that do not work without a spring element. A modern mattress contains several pounds to several dozen pounds of polyurethane foam, memory foam, or latex foam. This foam was selected for a single property extraordinarily valuable in survival: thermal insulation. Foam traps air in a cellular structure that dramatically slows heat transfer, which is why it keeps your body heat from dissipating into the mattress frame while you sleep. In a collapse, that same property keeps your body heat from dissipating into a cold floor, a frozen wall, or the winter air outside your shelter. Foam stripped from a mattress and packed into wall cavities, stuffed into gaps around windows and doors, layered over a sleeping surface on concrete, or wrapped around water pipes to prevent freezing, provides insulation comparable to commercial building insulation at zero cost. A single mattress contains enough foam to insulate the floor of a 10x10 room, putting a meaningful thermal barrier between your body and the ground. This is critical because ground contact steals body heat through conduction roughly 30 times faster than air contact. Foam can also be cut into custom shapes for padding splints, cushioning improvised seating, creating gaskets for sealing containers and pipe joints, and forming flotation aids. Polyurethane foam is closed cell or semi-closed cell, meaning it does not absorb water readily and provides buoyancy. A block of mattress foam in a waterproof bag becomes a flotation device for river crossings. Strips wrapped around a pack frame's shoulder straps turn a painful carry into a tolerable one. Foam wedges placed under an injured person's legs elevate extremities to manage shock. The outer layer of a mattress is a tightly woven fabric, typically cotton, polyester, or a blend selected for durability, breathability, and resistance to tearing. This fabric, cut from the mattress and separated from the padding beneath it, produces large rectangular panels of strong woven material, serving a dozen textile applications. A queen-sized mattress cover produces roughly 50 to 60 square feet of usable fabric when laid flat. That is enough to construct a basic rain shelter for one person, create a full set of window blackout panels for a small room, or cut into bandages and wound dressings that could last for weeks. The top and bottom panels are separate pieces, so a single mattress gives you two large fabric panels plus the side strip, tripling your usable material. Mattress fabric torn into strips produces cordage stronger than most improvised alternatives. Twist two strips together, and you have textile rope that handles lashing, binding, and light hauling. Sewn into a bag shape, the fabric creates carrying sacks and water pre-filter bags that remove sediment when you pour collected water through the weave. The fabric is also flame retardant by federal regulation. Every mattress sold in the U.S. since 2007 must meet open flame resistant standards, making it safer near fire than most scavenged textiles. Between the fabric cover and the springs or foam core, most mattresses contain a layer of cotton batting, polyester fiber fill, or wool padding. This batting, pulled free in sheets or clumps, is one of the most useful fire-starting materials you will find anywhere. Cotton batting catches a spark from a ferro rod and ignites almost instantly, burning slowly enough to transfer flame to kindling, but hot enough to ignite damp tinder that would resist a match. A handful pulled apart into a loose, airy nest is the ideal tinder bundle. It catches sparks, ember transfers from a bow drill, and focused heat from a fire lens more reliably than any natural material from the ground. A single mattress contains enough batting for hundreds of fire starts, which means you have solved your ignition problem from a single scavenging operation. Beyond fire starting, cotton batting serves as wound packing. Clean cotton placed into a deep wound provides compression and absorption that controls bleeding. It works as water filtration pre-filter material, removing coarse sediment. It serves as insulation stuffing for gloves, hats, and boot liners when packed into fabric shells. When treated with petroleum jelly, wax, or any available oil, cotton batting becomes a waterproof fire accelerant that ignites instantly and burns for minutes rather than seconds, creating sustained ignition that lights wet kindling where untreated tinder fails. Not all mattresses have wood frames, but box springs and many traditional foundations contain a rectangular frame of dimensional lumber, typically 114 or 116 pine or poplar, that provides the rigid structure supporting the spring system. Disassembled, this produces 8 to 12 linear feet of clean, dry, pre-cut lumber that has been stored indoors and protected from moisture for the mattress's entire life. Dry indoor stored lumber is a significant find in a collapse, where most available wood is either treated with toxic chemicals, wet from outdoor exposure, or part of a structure you would have to demolish. Mattress frame lumber is ready for small construction, shelving, door reinforcement braces, window shutters, or raised sleeping platforms. It splits cleanly into kindling and carves into utensils, tool handles, stakes, and small implements. Because it has been in a dry, climate-controlled environment for years, it burns more efficiently and cleanly than outdoor scavenged wood containing moisture. The corner brackets connecting the frame are typically steel L brackets or corner plates with screws, providing additional hardware like metal fasteners and bracket material for any small project. The whole mattress itself can be used as a structural and defensive component without stripping it at all. There are applications where the mattress is more valuable intact, and the primary one is impact absorption. A mattress placed against a wall, leaned against a window, or stacked in a doorway is a surprisingly effective barrier. The combination of spring steel, dense foam, and layered fabric absorbs and distributes kinetic energy across a wide area rather than allowing point penetration. A mattress leaned against a door from the inside adds a layer of resistance extremely difficult to cut, stab, or push through. Springs deflect and entangle anything penetrating the fabric, while foam absorbs the impact. It won't stop a high-velocity rifle round, but it degrades lower-velocity impacts, including shotgun pellets, handgun rounds, and blunt force tools being used to breach a barrier. Two mattresses stacked in a window frame block visual observation, absorb thrown objects, muffle sound, provide thermal insulation, and resist physical penetration far better than plywood or cardboard. Mattresses also serve as improvised stretchers. Two poles threaded through the fabric on either side create a rigid, cushioned carrying surface that is more comfortable and easier on carriers than anything built from scratch. They function as bridge surfaces over small gaps, distributing body weight across the springs. Stacked 3 or 4 high, they create elevated sleeping platforms off cold floors without construction, preserving the ground insulation advantage while getting you above the cold air pooling at floor level. Here is what one mattress gives you: up to 750 feet of tempered spring steel wire for snares, fish hooks, tripwires, tools, and mechanical springs. Several pounds of thermal insulation foam for floors, walls, pipes, splint padding, and flotation. 50 or more square feet of durable flame-retardant fabric for shelters, blackout panels, bandages, and cordage. Enough cotton batting for hundreds of fire starts and wound packing. 8 to 12 feet of dry lumber for construction, carving, and efficient firewood. And the intact mattress itself as an impact barrier, a stretcher, a bridge surface, and an elevated sleeping platform. All of it comes from an object that exists in virtually every room of every building in the country, weighs between 50 and 100 pounds, can be transported by a single person dragging it by one corner, and that nobody else in the collapse is going to think of as anything other than something to sleep on. Which is fine. Let them sleep on theirs. You will be too busy turning yours into a trap line, an insulated shelter, a fire-starting kit, a medical supply, a construction material cache, and a defensive barrier to worry about a comfortable night's rest. Although, if you play it right, you will have plenty of mattresses left over for that too. If this breakdown changes the way you look at the everyday objects in your home, please subscribe and like the channel. We are uncovering the hidden utility in the world they taught you to take for granted. Prepare for the future. The next survival treasure is waiting to be uncovered.